All right, welcome to Module 3. This is the pre-module review. We are going to look at converting fractions to decimals and solving proportions as a way to help us recall how to work with proportionality. So the first thing we're going to do is look at turning fractions into decimals. And the big piece of that is the access to a calculator, because you are going to be doing some division. So if I have 3/4, for example, and I want to know what that is as a decimal, all I have to do is the top divided by the bottom. So I'm going to do 3 divided by 4. Calculator. 3. Division is the line with the 2 dots. Kind of looks like a fraction, except instead of dots, we usually have numbers in a fraction. So 3 divided by 4, 0.75. It's that easy. Here we have 2/5. If I want to turn that into a fraction, I'm going to do, there we go, 2 divided by 5, 0.4. Here we have a mixed number. We have 5 and 1/4. So before we do any division, I'm going to take this whole number, 5. I'm going to move it over here because I know I'm going to have at least 5 point something. I'm going to have 5 and a little bit more, 1/4 more. So we have 5 as our whole number in the ones place, and then we have 1/4. To find 1/4, we do 1 divided by 4, 0.25. So 5 and 1/4 is 5.25. Our last example, we have negative 3 9/10. Again, we have a whole number here. Actually, this is an integer because it's negative. So I'm going to take that integer and I'm going to go ahead and put it over here. Negative 3, and I know that I've got 9/10, so it's going to be 3 and a little bit more, so 3 point something. To get that something, I'm just going to divide my fraction. So I'm going to do 9 divided by 10, 0.9. So negative 3 9/10 is the same as negative 3.9. So there's our review on fractions to decimals. I'm going to adjust my camera real quick. There we go. Now let's talk about solving proportions, which feels like a little bit of a jump, but it will be important for the work we're doing in this module. There's 2 ways we're going to look at it. The first way is to multiply to get the known number and then multiply to get the unknown number. Here's what that means. Here we have 2 ratios, or 2 fractions that are equal to each other, equal sign. So 4/5 is equal to m over 15. We don't know what m is. That's the unknown number. So if our first step is to multiply to get the known number, I need to know how many 5s I need to get to 15. What do I multiply 5 by to get 15? I know in my head that I multiply 5 times 3, but if I'm not sure, I can use a multiplication chart, or I could use a calculator, and I could do the opposite, or the inverse. I could go backwards. I could do 15 divided by 5 to get my multiplication factor there. If I multiply the bottom times 3, that means I have to do the same thing to the top. I have to multiply 4 times 3 to get m. 4 times 3, you can use your calculator, multiplication chart, or if you know it, 4 times 3 is 12, which means that m equals 12. So we multiplied the bottom here to get the known number, and then multiplied the top to get the unknown number. Sometimes it might be you multiply the top to get the known number and then the bottom to get the unknown, because m could be either place, and we have to solve for it. The second method is to cross-multiply. So method 2, we cross-multiply, we set up our equation, and then we divide. When I say cross-multiply, I mean you're going to make circles with opposite corners. So we have 2z, and then we have 3 and 8. And I'm going to go ahead and I'm going to multiply these things. It doesn't matter which pair ends up on which side of your equal sign. I'm going to do 3 times 8, and that's equal to 2 times z. And I'm using the dot to represent multiplication here. 3 times 8 is 24. 2 times z is just 2z. So here's our equation now. We cross-multiplied to get our equation. 24 equals 2z, or 2 times z. Now we have to divide. If you remember from last year when solving two-step equations, this is a one-step equation, we have to use the inverse or opposite operation. If 2 and z are multiplying, and I want to get z by itself, I have to do the opposite. I'm going to divide. I'm going to divide by what I want to get rid of, which is the 2. 2 divided by 2 is 1. It cancels out. Now I'm left with z by itself. But if I divide this side of the equation by 2, I also have to divide this side of the equation by 2. 24 divided by 2, you can use a calculator, gives you 12. And here you have z equals 12, or 12 equals z. All right, move on to the 3.1 watch and write.